This video is divided into three parts. In the first part, we'll create shop drawing of our column. In the second part, we create the quantity takeoff and bar bending schedule of column. And in the last part, we'll learn how to place views in our sheet.
Welcome to Civil Builders. I am Engineer Arsalan.
In the last video, we created a column and assigned reinforcement. Now let's move forward. In our drawing area, we have created grids and marked their annotations. Now we see how we can create the column between these grid lines. To do so, we use the command CL. Then we select Add Grid option from the Modify panel, and then simply dragging toward the left side and check this Finish option to complete our placement. Now we create our detailing level like this. There are 16 bars of 8 number, and the spacing between their stirrups ranges between 4 inch and 6 inch. To place the rebar, we choose rebar option, and then I use 6 number bars, and I select its shape, adjust its plan and its number. As there are 5 number of bars at the top layer, so I choose 5 option, and then simply click in the column to complete its placement. Similarly, there are 5 bars at the bottom and 3 bars in the middle. So I choose 3 number for the middle bars. Now I can copy our bars. We can use arrows to move our rebars. For stirrup, we follow the same procedure, but we change the work plan and shape. First, we select the rebar tool, and then select its shape and the rebar number and spacing. Then we select the plan. For stirrup, we use parallel to plan option. And then simply click on the column. For assigning the mirror rings, we use by 2 points option, and simply click in the column and drag toward the right side to complete its placement. For section, we use View tab. To access the section, double click on its head. Change its detail to fine and scale to 1 by 2 inch. We can change the color of our rebar element by overriding its material properties. Simply click and from the edit type modify its material properties. In the color we use dark blue color. And similarly for the stirrup, we follow the same procedure. The color of my rebar element got changed. Column is divided into 3 different regions. In S1, our spacing is 4 inch. In S2 region, our spacing is 6 inches. To divide this elevation between 3 portions, use DL command. Then simply click. Then I use DI command to check the distance, and then press that equal button. It automatically divides this region in 3 equal parts. Now we can easily adjust the spacing of our stirrups between these regions. I simply click on element and from the rebar side I change its spacing. For 3D view, I click on the home icon. Perfect display option to shade it, and increase by transparency of an element. And I select my bar and apply the copy command. Copy my rebar. Now we see that outer and inner rings are placed at a distance of 4 inches at the top and bottom, because the spacing of the stirrups at the top and bottom are 4 inches. Now we also place the rebar rings at the middle. We follow the same procedure. We just copy an element and then we'll modify its spacing from the rebar side. I use the CEO command for copying an element. Then I change the spacing to 6 inches. Now we successfully place our rebars in these regions at a spacing of 4 and 6 inches. For tagging our rebar element, we use TC command. And then simply taking on our elements. It shows that there are 8 number of bars in this region, and there are 3 numbers and 6 inch spacing. For dimensioning, we use DI command. Now we'll see how we can modify the vertical bars and add laps to the bars. I'll move to the 3D sections and then add the footing using the structure panels and add column option and click finish to assign the footing. We can modify our vertical bars by selecting them and dragging toward the footing. We can add the hook length to these bars by selecting the bars, and then from the properties panel we choose hook at 10 to 90 degrees, then a hook length is added. Okay, repeat the same procedure for all the other bars. We can change the orientation of our hooks by pressing the space bar. And now we create our lap. So according to ACI, the overlapping length is 40D. In our case, the diameter of our bar is 0.75 inches. So we have to provide an overlap of 30 inches. To create an overlap, first we create the model line by using DL. Then we provide an offset of 15 inches on both sides by using the OF command. This is the region where we have to provide an overlap. So to do this, I'll select my vertical bars and then I press copy command and I copy my rebars. Now I select all the bars that I copied above, can change its shape and its material. And I simply drag and adjust its overlap. We use arrow to shift the rebar. We can control the visibility of our rebar For this purpose, we have to select our rebar element, and from these options, we can choose whatever that suits our need. For instance, if I want to show just the middle bar, I choose this option. And if I want to show the first and the last bar, I choose this option. I can also customize this. I can select this option. And from the select then, I choose the bar that I want to show. For example, I want to show this bar and this bar and this bar. And then I'll choose the finish option. Only these three bar elements is shown on our screen. I simply repeat this procedure for the rest of our rebar elements. We can also create the multiple rebar tag from the annotate tab. I use align multiple rebar annotation option, and I just need to select my rebar element, and I choose vertical option, and then simply click. I can also modify it. Similarly, I repeat the procedure for the next below sections. In our section, the middle bars are shown straight, but in our 3D views, these bars have 90-degree bend at their end. To reflect this bend in our section, we use the bending detail option. We simply drag and place inside our column. These bending detail have shown text. We'll go to the edit tab and hide the text. Now in this view, these bars are shown, but they shown some duplicate. So I'll select on that element and right click and choose toggle visibility option. So I repeat the same procedure for the other bar element. To view the plan section and 3D in the same window, we use the tile view option from the view tab. First, we'll do some adjustment and then apply the command. I select the element and type BX for zoom view. To replicate these bar detail to the rest of the columns at once, I use Propagate tools. First, I select the column, and then from the filter tab, I choose structural rebar option. And then from the host, I choose Propagate bar and select align by host. And then I simply click in the column that I want to duplicate the rebar details. Now we move to our next part, that is estimation and quantity takeoff. So to estimate the quantities of our column, I go to the project browser. From schedule and quantities, I'll click and choose the new schedule and quantities option. I can access this dialog box from the view tab also. And then from here, I choose structural column. And then I press OK. Then a new window pops up that shows the different parameters. In these schedules, we have to calculate the volume. So I choose volume. And to shift this volume from the left to the right side, I choose this arrowhead. And then I also use length mark. And I also choose the levels, top levels, and base level. To rearrange this, I can use this arrowheads. So to move the volume down, I click on this arrow. If I don't need this, then I select this option. Then I simply press OK. Finally, we create our schedules. Here there is a mark, and that is C3, and we have created our column from the level 1 to level 2, and its length is 10 feet, and the volume of our column is 50 cubic feet. We can adjust these fields from the properties panel. If I want the total, then I go to the edit field options. And formatting, I choose the volume option and I choose the calculate total and press OK. It gave me total volume of the column. We have two different methods to estimate the quantity of rebar. In the method 1, we just input the value of density and volume, then we get the mass in kgs. And in the method 2, we use this formula. Now let's start calculating the rebar quantity in Revit. Well, from the schedule tab, I use the structural rebar option and then press OK. And I choose the required field. To calculate the weight, we select Add Calculated Parameters, and then here I type the name, that is weight, and I choose the discipline to structural, and from here I select the mass. Then I click in these three dots and I choose reinforcement volume. As we know that mass equal to density into volume, and the density of our steel bar is in pound per cubic feet is 490. So I simply type here the weight is shown in pounds. To modify this, I use added field, and from the formatting, I use this field format option and I change this to kg. Now our weight is shown in kg. This is method 1. By using this method 1, we can calculate our weight. We can check these with our Excel sheet. Bar is 6 number and its length is 20.5, and we get our mass is 13.984. We follow the same steps for the second method. We have to create a new schedule and quantities, and from here I choose structural rebar and then name it structural rebar method 2 and then press OK. And from this panel I choose the required parameters. For weight calculations, we use calculated parameter. Rename it, and then from the discipline I choose structural, and here I choose mass. And then I add formula by using these three dots. I choose total bar length, and I have to multiply it for 3 number bar. Our factor is 0.375 pound per feet. So I add here 0.375 pound per feet. And then press OK. The weight is in pound. To change its unit in kg, I use this field format from the formatting option, and I choose kg here. Then I press OK. And from the filter tab, I filter it by bar number. Now in our schedule, there are all the bars and 3 number bars. To calculate its total quantity, I select the calculate total from the formatting tabs. And I change its alignment to center and then press OK. Now I get a total quantity. In case finally we reach the last part of this video. So in this part, we create a sheet and place views in it. So to create a sheet, we go to the view tab and hit this sheet icon. And then I choose the template and press OK. So our sheet is now created. To rename or modify its sheet number, we can use the properties panel, or we simply click in our project browser and we can rename it from this dialog box as well by simply typing. Now to place views in this sheet, we use this view icon, and from this dialog box we select the views that I want to place in our sheet. For instance, I want to place by section, choose my section, and then I press OK. And simply click in our drawing area. So our views is placed. We can also place our views by click our views and then dragging to our sheet. Similarly, we can place 3D views in our sheet also. Now we do some adjustment. To create the banding detail of these stirrups in the vertical bar, I select on the bar, and then from the banding detail option, I can draw its detailing. Moreover, to create the bar bending schedule, first I have to verify my schedules. I click on my schedules, and then from my field, I add the bending detail parameter and press OK. Then I create a new sheet and place schedule by dragging and do some adjustment to make it more readable and presentable. That's all for today's session. In the next video, we'll learn how to create foundation, assign reinforcement, and do the detailing works. Don't forget to hit the subscribe button and turn on the notification bell so you never miss an update. Your support helps the channel grow and let me create more valuable content for you.